Good day, students. Welcome to math.serve.com. In this clip, we're going to be going over problems 21 to 25 of the Texas Higher Education Assessment. And don't forget to visit our website at math.serve.com for access to a wide variety of math tutorials ranging from algebra all the way to calculus. All right, let's take a look at problem number 21. It says, Robin Chan collected $175 in the second week of her school charity drive. This is referring to what she collected in the second week was $35 more than she collected in the first week. How much did she collect in the 2 weeks? All right, so first piece of information we know is that in the second week, she collected $175. In the first week, we don't know exactly how much she collected yet. But this second sentence gives us an equation that we can solve algebraically to determine how much she collected on the first week. And then we'll be in a position to find the sum, which is the first week's collection plus the second week's collection. All right? So let's go ahead and use the second sentence to formulate an algebraic equation. So this referring to second week's earning, how much she collected in the second week was or is equal to 35 more than she collected in the first week. So it's going to be first week plus 35. Okay, so let's see. This is an equation with two variables. Let's see if we can use this information here to substitute. And we totally can. Second week's earning was 175, so we plug it in here. We have 175 is equal to the first week plus 35. Okay, so this basically tells us that the first week has to be 35 less than the second week, which is 175. So what we're going to do algebraically is just subtract 35 from both sides. And then you subtract 35 from 175 and you get $140. You can do this intuitively too. If you think about it, if 175 is 35 more than what? You just take 135 out of 175 and you end up with 140. Okay? So the first week's collection is $140. But the problem asks for how much you collected in both weeks. So we simply add them together, and we get 5, 7 plus 4, 11, carry 1, $315 is how much he collected. And 2 weeks combined, answer is option letter B. All right, let's take a look at number 22. It says one factor of the quadratic trinomial x squared minus 2x minus 24 is. So all we are just going to do is we're going to factor this completely and see which of the factors match one of these options right here. Now, since this is a quadratic trinomial, we can factor this by grouping. If you look at the options we have, they are nice factors, so factoring by grouping should work here. So to factor by grouping, we're going to play the x game. AC goes on top, B goes on the bottom. So we have A is the coefficient of x squared, B is the coefficient of x, and C is a constant. All right. So AC, there's a 1 here, is negative 1 times 24, which is negative 24. And B is negative 2. Now, what's two numbers multiplied to give you 24 and add to give you 2? Let's go ahead and figure that out. Let's write down the list of pairs of numbers that multiply together to give us 24. And then we're going to see which one can be combined to give you 2. All right, so 24. 1 times 24 will give us 24, but combination of these two will give us 25 or 23. 2 times 12 will give us 24. Combining these two will give us 10 or 14, which is not 2. 3 times 8 gives us 24. Combining these two will give us 5 or 11. That doesn't work. 4 times 6 can give us 10 or 2. Voila, that's what we want. All right. So we have a variation of 6 and 4. So as the sum is negative, that means that the bigger of the two addends must be negative. All right? And then please check your X scheme to make sure it's correct. All right, and that's the case here. Okay, since it's good, now we can skip factoring by grouping since A is 1. Anytime A is 1, you don't need to factor by grouping. You can jump to your factored form, which is X. You take the first factor, -6. So X minus 6 times X. And then you take the second factor. What is the second factor? +4. Okay, X was 4. So let's see which one matches. Oh, there you go. Option letter C is the correct answer for this problem. All right, let's take a look at problem 23. This involves dividing rational expressions. So let's go ahead and write this down. We have x squared minus x divided by x squared plus 3x plus 2 divided by x squared plus 2x over x squared minus 1. So anytime you're dividing two rational expressions, you're going to basically express it as follows. The first one multiplied by the reciprocal of the second. Okay, so divided by x squared minus 1 over x squared plus 2x. So to divide is the same thing as multiplying by the reciprocal. All right, they mean the same thing. So just change this to a times and then reciprocate this rational expression right here. So in order to simplify this completely, we have to factor all four polynomial expressions. Let's start from the top. The numerator on the left. Okay, numerator on the left is x squared minus 1. Let's go ahead and factor that. X squared minus x, I meant to say. We can write this as x times x minus 1 times x. The GCF that can be factored here is just x. So let's factor out the x. We have x times x minus 1. Next polynomial we'll want to factor is the denominator on the left. I'm just abbreviating. Please bear with me here. Denominator on the left is x squared plus 3x plus 2. This is a quadratic trinomial that can be factored using the x game as we did in problem number 22. All right, to make your nice little x, AC goes on top and B goes on the bottom. AC is 2, B is 3. What two numbers work? The only two numbers that multiply to give you 2 is 1 and 2, okay, since 2 is prime. Now, can we skip factoring by grouping here and jump to the factored form? The answer is yes, because A is 1. All right, so the factored form is x plus 1, first factor in our x game, times x plus 2. All right, now we have the rational expression on the left factored completely. Now we're going to shift our attention to the rational expression on the right. Next thing to factor is the numerator on the right. So numerator on the right, that one is x squared minus 1. So let's see, how do we factor out x squared minus 1? If you inspect these two terms closely, what you notice is that these two terms are squares. They are perfect squares. So we can use the perfect square formula to factor these. Remember, a squared minus b squared factors into the square root of the sum of these two and the square root of the difference. So you just root the first and the last, and then you find the sum and difference of their square roots. Okay, so it's going to be a minus b, or a plus b times a minus b. All right, that was the formula for a difference of squares. All right, so if we apply it here, we just root x squared, and then root 1, since they're perfect squares, and then you add and subtract the square roots, okay? So this difference of squares expression can be simplified into x minus 1 times x plus 1. Okay, so that was the factored form of the numerator on the right. Next thing we need to factor is the denominator on the right. All right, a lot of factoring here. So the denominator on the right, let's scroll up, is x squared plus 2x. So let's go ahead and factor that. X squared plus 2x. So if I decompose both terms, I'll have x times x plus 2 times x. And what can I factor out? Factor out an x from both of them. And then the factored form is x times x plus 2. All right? So we have everything factored nicely. Let's go ahead and organize them back into the problem. So we're now going to have, let me put a line here so we don't confuse our work with the options. We're going to have, let's see, numerator left, x times x minus 1. The denominator is x plus 1 times x plus 2 times x squared minus 1. We factor that into x plus 1, x minus 1 using the difference of squares formula. And the denominator, you just pull out an x times x plus 2. Okay, so there goes the factored form. Now let's go ahead and cross reduce. You can reduce any denominator with any numerator. All right, it doesn't matter if it's vertically or across or diagonally, doesn't matter. All right, so all these denominators are together and all these numerators are together. So let's see, x plus 1 goes here once, x plus 1 goes there once, x goes here once, and x goes there once. So you're left with x minus 1 times x minus 1 divided by x plus 2 times x plus 2. All right, if you expand the numerator, you double distribute or you FOIL it out, first outer inner last. Since you're dealing with binomials here, you're going to have, you can put in the arrows. You're going to go first, outer, inner, last. Same story with the bottom. So let's do the top. We're going to have x squared minus x plus 1. If you do the denominator, you have x squared plus 2x plus 2x plus 4. All right? And now if we simplify it, we are going to end up with x squared minus 2x plus 1 divided by x squared plus 4x plus 4. So our final answer is option letter D. All right, let's take a look at problem 24. We have to simplify this rational expression. So what we're going to do is decompose everything in the numerator and the denominator and see what we can factor out, okay? So we just have a monomial on top, which is 3 times c. Upon decomposition, that's what we have. But we can break 24cx down and also 18. Let's go ahead and do that on the side, all right? So 24 is even, so I can take 2 out of it. 2 goes into 24 12 times. Take out 2 from 12. Since it's even, you get 6. Still even, I can take out another 2. And then that's 3 we have left there. So that's the prime factor decomposition of 24. Let's try 18. It's even, take out a 2, 9. And then 9, take out a 3, and a 3. Okay? So let's put that back. 24 is 2 times 2 times 2 times 3 times c times x, because of the cx right here, minus 2 times 3 times 3. That's 9 times c times c. 9 times 2 is 18c squared. Now in the denominator, we can only reduce common factors with the numerator. Okay, so what's the common factor in the denominator? What factors repeat in these two terms? This is one term, and this is another term. What factors are common? The factors that are common are as follows. 2 is common to both sides. 3 is common also. And a c is common. So I can factor out 2 times 3 times c. Or I can factor out 6c, okay? So, well, let's leave it in a decomposed state. Upstairs, we have 3 times 3 times c. Downstairs, we can factor out 2 times 3 times c. And when we're left with 2 times 2, which is 4. 4x minus 3 times c, 3c. Okay? Now, what can we reduce in the numerator and the GCF we factored out? We can take out 3 goes here 1, 3 goes here 1, C goes here 1, C goes here 1. So our answer is going to be 3 over. Now this 2 right here, we can distribute it back, but let me just show you step by step so we don't get confused. So in the options here, you notice that all the denominators are expanded. So that's a hint for us to expand our denominator completely. Okay? So if we do that, we distribute the 2 back into this quantity that we factored 6c from. If we do that, we're going to have 8x minus 6c. All right, so answer for number 24 is option letter A. All right, problem 25 is testing our proficiency with the laws of exponents. So let's go ahead and try that out. We're dividing again, so what I'm going to do is express this as a fraction. Remember, we talked about this earlier in problem 23, that when you're dividing two fractions or rational expressions, it's the same thing as multiplying the first by the reciprocal of the second. That's the same thing as dividing, all right? So we're going to have a to the 3/2, b to the 3rd, c to the 5th, over a to the 2nd, b to the 1/3, times, you reciprocate this quantity right here, 1 over a squared b to the 5/3, d to the 1/2. Let's freeze for a second. What just happened here? Remember, when you're dividing fractions, you take the first one times the reciprocal of the second. So I just reciprocated this rational expression right here. Okay, so what is the law of exponents when you're dividing? When you're dividing exponents of the same base, let's say you have a to the x over a to the y, the rule is you subtract the powers. Okay? So the power on the top, you subtract the power on the bottom from the power on the top. The power on the numerator, you subtract the power on the denominator. All right? So we're going to deal with a, b, and c individually. Actually, just a and b, since we don't have any c's repeating or any b's. All right? So we're going to have upstairs a. This is the 3/2. I'm going to be subtracting these two powers downstairs. Minus 2, minus 2. Okay, so you take the power on the top and you subtract the powers of the terms with the same base downstairs. So we have a 2 and a 2. B to the 3rd. Now what am I going to subtract from b to the 3rd? Downstairs, we have two terms that have the same base as b, which is this and that. So we're going to subtract their powers from the power on the top. Okay? And then c to the 5th has nothing downstairs, so we're going to leave it intact. And then downstairs, we have d to the 1/2. Just stays alone since it doesn't have anything that we're combining it with. All right, we're dividing it by, so we just leave it alone. All right, now this is a fraction problem. We're going to have to resolve this fraction and then that one, and then we're going to put it back in, all right? So let's deal with base a first. This is scratch work, all right? So we have 3 over 2 minus 2 minus 2. How about we write everything as fractions? The denominators must be the same before we combine. So we have to find the LCD of 2 and 1, which is 2. So multiply this by 2 top and bottom. And multiply this by 2 top and bottom. Okay, so we have 3 over 2 minus 4 over 2 minus 4 over 2. So 3 minus 4 is the same thing as 3 minus 8, which is negative 5. So it's going to be negative 5 over 2. That's what the power of the A is going to be, the A base. And please don't drop the negative sign. It plays a significant role in the appearance of our solution, okay? So please don't drop that. Now let's take a look at base B. Base B, we have to combine these three fractions. 3, minus 1/3 minus 5/3. Now the reason why I'm doing this work on the side is if I do everything here, it's going to get messy and I can confuse myself in my own work. So whenever you're doing scratch work like fractions or other things, within a complex problem, you want to extract the sub-steps and work on them independently, all right? That was the same strategy I used in number 23 when I extracted the numerators and the denominators for factorization purposes, all right? So keep that in mind. All right, so let's go ahead and resolve this fraction. We have three fractions. Denominators are not alike, so we have to find the LCD of 1, 3, and 3, which is 3. So we'll simply multiply this fraction by 3 top and bottom. And that yields 9 over 3 minus 1 over 3 minus 5 over 3. When you work that out, 9 minus 1 minus 5 is 9 minus 6. 9 minus 6 is 3. 3 over 3 is 1. Okay? So let's go ahead and apply our answers back. So we're going to have a to the what? A to the negative 5 over 2. B to the first power. C to the fifth. And then D to the 1/2. Okay? Now this a to the negative fifth is ill. It has a negative exponent, which is not acceptable. So in order to address this negativity, we must reciprocate this term. If it's downstairs, it goes up. If it's up, it goes down. All right, so if we reciprocate a to the negative 5 over 2, it's going to end up in the denominator. All right, so we're going to have b to the first power, which is just b. We don't have to put a 1 there, times c to the fifth, divided by this a to the negative 5 over 2 comes down as a to the 5/2. All right, the negativity goes away due to reciprocation. All right, and then d to the 1/2 remains unchanged because it didn't have any other base exponent with the same base to combine with. So there goes our final answer. We can clearly see that option letter D is the correct answer here. So thanks so much for taking the time to watch this presentation. Do feel free to subscribe to our channel for the remainder of the tutorials for this review series. And also, please post a comments to let us know what you think about this clip, any questions, clarifications that you have, and also any suggestions to help improve the quality of our presentations. Don't forget to visit our website at mathwithserve.com. Thanks again for watching and have a wonderful day.